every session 2 hours. So we can take break at 10:45 for 15 minutes. Then we take the second session 2 hours till 1 o'clock. From 1 to 2 we'll have lunch break, and after that we'll come at 2 for a last session for 2 hours. So 6 hours per day. 3 sessions, 2 hours each.
But lunch break is prepaid for all of us, right?
No. Okay, so please.
Thank you.
Also the emergency and
Emergency.
so there is no any fire alarm testing today. In case if there's any fire alarm, we need to get out to the assembly point, which
Okay.
is just beside this.
We have this side.
This side. There's one this side.
Assembly point here.
Yeah.
And this is an emergency switch.
Yes,
Okay. So please.
no problem. If there is a fire, we won't wait.
Of course.
Is the sound level okay? Yeah, very good. Okay, thank you very much for the introduction. It's nice to be here and nice to see the PST all lit up as it should be. We were here yesterday, last night, and trying to get this working, so it's very good. Yeah, Stuart's uncle is my name, and as we've been introduced, we have Jani and Henrik as well. Terco is a company in Sweden. We've been operating for over 50 years in power systems, high voltage, and a lot of different equipment. But this is one of our major products that we have. Myself, I've been on about 12 or 13 installations of this product around the world. And the one that has been purchased here by Oman is the complete system. So you have everything, and you have a lot of SCADA system as well. Yeah. The training that we'll be doing is very hands-on, not so much theory. The goal for this training is that by the end of the 2 days, you will be very confident in using the equipment. You will know which buttons to push and what you can do to not cause any problems on the system. It's very easy. There are a lot of protections in the system as well. So there's not a lot that can be done wrong. Okay. I'm going to begin with the external connections of the PST, just so that we know how everything is connected. Then I'll talk about the internal connections, how the instruments are connected together, and then we'll get straight on to connecting up the PST ourselves with our hands. Yes. So, external connections. We have a 3-phase, 415 volts, I think, here. Is that correct? Yeah. Into our first unit. I should actually do this one here. In here. And our main power all the way along the back of the system is called X1, and we'll go along the back and have a look and see what I'm talking about here. But for all of the modules, these are simply taken in a daisy chain all the way to the end. And in the very last one, we have something which is very important. This is called our end plug. And our end plug helps to take our emergency stop signal all the way through all of these units and back again. So if this is missing, then the PST system thinks that there has been an emergency stop pressed. But I'll explain that one more time when we're in the back. And the reason I explain that is because if someone wants to be a little bit sneaky and takes it off, then you can't start the system. And that's probably the main reason why. We have one more connection on the back, which is for transfer blocks. And transfer blocks we have, I'm just going to move around the front here. In most of the modules, transfer block 1.1, we have the same electrical point. Here, transfer block 1.1, and there, and there. And that means that we don't need to take cables all the way across the front. So those are also connected a lot. So that's our power and our transfer blocks, and also the emergency stop. So there are emergency stop buttons in each of the units. They are all connected in series. So if you hit one of them, the complete PST will shut down. Yes, but let's take a quick look around the back just to see what I'm talking about here. here we see our mains power going from the first unit to the second and continuing and continuing.
What's the cross-sectional area of these cables?
Sorry, the
Cross-sectional area, is it 2.5?
1.5 or 2.5, I'm not sure.
All right.
Not sure. Yes. So that's our main power, and then we have a second one, which is X3, also doing the same. Yes. If we can go down to the end one there, that one is missing, then we can't start the PST. It's the same as if we pushed emergency stop.
Should be in.
It should be in. So if for some reason you come in and you start and nothing happens, check that one. Yeah, it's
Same
someone
thing
is
if we
playing.
decide, for example, to take this one out, for example, then we need to shift that one to the next one.
This one should always be in the last one.
Okay. Let's say this one is not functioning for a reason or another. But
Yes.
still we need to have the simulator running.
Yes, exactly. So we take this one away, and as you said, yes, we'll put it in the last one here. Yeah, exactly. Yeah, probably won't be an issue. But connections, we have this system with SCADA. If I do it like this. And I think we saw on the back, also we have some communications LAN cables. And this is how the master computer is connected to the PST in the same way. And here we have no end plug, you don't need to worry about that. If we look at what happens inside here, inside each of the PST units, we come into a switch, which is then connected to our main PLC. And the PLC is used to control logically the switching. So if we want to make a connection that's not allowed, the PLC will always evaluate first before it connects the contactor behind the switch. So we have connections here. Also, we might have some relay connections, some protective relays from ABB. Here, and also we have all of our instruments, which are along the whole thing. So the instruments can communicate via Modbus, a Modbus bus inside, and to connect the Modbus bus to the LAN, we then have a converter. So we have LAN on this side and Modbus RS 485 on this one. And this goes out to each of our instruments. The IED is connected directly with the LAN that has that protocol, but just the individual measurement instruments, the bar graphs and the displays and things. Yes? Question? PLC is, exactly, that has also the LAN connection. Not Modbus, no. It's connected directly to the network switch and out to the SCADA master. No, there's in most of the units there is one PLC. So there's about 1, 2, 3, 5 PLCs in this system. They are from General Electric, complete industrial PLCs. Yes, and that's how we communicate with the SCADA system as well.
The program design is given?
The program, we will provide backups for all of the programs. Yes, that shouldn't be needed, we hope. We'll be providing full backups for the IEDs. And it's also been requested that we can set passwords on the protective relays so that students cannot change them. which we will do on the last day, so that when we are working with them, we can just go in and change everything if we want. That's a big part of the training. Okay. External, internal communication. Yes. Okay, that's all I wanted to talk about on the board, and it's time to get our hands dirty and step away. Yes.
General question.
Yes.
Thank you for your presentation, and thank you for this, Terco, because it comes in my mind when you said ABB,
Mhm.
relay. Is it possible, nowadays there is a smart grid,
Mm-hmm.
it's microgrid,
Yes.
and every simulator now, let me finish, every
Hmm?
simulator nowadays, it includes all this.
Yes.
I have been contacted with ABB for some business, and they have somewhat they call it phasor measurement units.
Yes.
Okay, is it possible to upgrade? Because nowadays, if you bring some outside engineer to train them on this simulator, they expect some of the new technology which it has
Sure.
been applied nowadays over the world. Okay,
Yes.
but unfortunately, it is not yet applied in GCC. Is it possible to upgrade this simulator to include this PMU,
Mm-hmm.
which we can get the signal from the telco simulator with some GPS and antenna
Mm-hmm.
to get this data from this BMU, and I can contact, I know the person, personally I know him. I can contact the ABB to help us, or you can be in coordinate with us to help us with one of the application of this BMU.
Okay.
This is my concern, because honestly speaking, I don't like to mention the manufacturer, most of them, now they include this part of this smart grid.
Mm-hmm.
Because any engineer to be trained now, he expects. Is it possible?
Sure. This is our very next product, which we will be producing. Henrik is as enthusiastic as you are on this one. Today we don't have this product, but we're hoping that by January 2018 we will have this product. It will be an addition to the PST. So we have begun discussions, but today we don't have a finished product for that.
This one, if we brought these devices from ABB,
Mm-hmm.
is it possible you can help us to be connected here to get this function, or we just to wait for 2018 till you get what is your product actually regarding this?
We are making a phaser measurement unit
Phaser.
for use with the PST.
Oh, really?
Yes.
Great.
Yeah. So we have, you have the only load flow module that we have produced, which was new this year. This is the first one. And the next step then, after we have the load flow module, is to then measure the phasers in this system. So yes. So this is the next natural step for us to develop. Yeah.
Could you just, if possible, to just give us some material which help us to understand what is your product for 2018?
I can. Aaron, who is with Big, we don't have anything today.
Yeah, no, later, you can
yeah.
send it. Also, is it the one which your product, it will be fitted to this simulator?
Can we upgrade this one?
To upgrade it to this
Yeah,
one?
it will be an addition.
An addition.
Yeah.
This
So we spoke about this when you were in Stockholm,
is excellent.
and also it's a very exciting product. So we want to have this as well. But yeah.
Okay. Really happy and glad to hear this, for this Terco to
Mhm.
provide this new technology
Yes.
of this
Mm.
synchron phasor. Thank you.
Sure. No problem. Okay. Yeah. So let's move over to the PST now. Two generators. So each generator has then a step-up transformer. Delta star transformer. From there, we go to a line model of any type. We have different types of overhead lines and cables as well. Then we have a substation where we step down the voltage, a step-down voltage substation. Medium voltage lines, I should say. High voltage, medium voltage. From there, we have our power factor controller, and then onto our loads. So this is the system that we'll be looking at today. There is also the load flow module, which is at the end there, but Henrik will be taking that tomorrow.
Sorry if I interrupt you.
Yes, no.
Regarding to power factor correction, if you go to industrial now, they use online,
Mm-hmm.
microprocessor.
Sure.
The one which uses just a switch capacitor.
It's just a switch capacitor banks,
But
yes.
is there any in future use this micro? Because
We want to, but first we want to get the PMU.
Do you think about an SQC or StatCom or something like that?
not a StatCom, whatever, But nowadays, if you go to industrial,
Yeah.
they have this online power factor and they use a microprocessor, For this, they measure
For
the
the
power
regulation?
factor, the
Yeah, for the-
controller, and switch on and off this.
Yeah, for regulation, you mean?
Yeah.
Aha,
we
okay.
have
This
yeah,
one is
there's a-
equipped.
there's a-
Yeah.
It is equipped
It is
with
equipped.
Yeah,
automatic
it's
power
a
factor
microprocessor-based.
Sorry for interrupting you, but I would like just to say this is engineer would you like to, because we would like to teach them here, and when you go outside, at least they don't want to see a different.
Okay.
This is what. Thank
Yes,
you. Sorry
no
for
problem.
interrupting.
No problem. I can mention on that one, if students are to follow it, it will teach you everything you need to know about this microprocessor-controlled brain. So,
It is there.
yes.
It is there.
yes.
Thank you.
We will also be giving you all of the manuals in soft copy form, but we'll do that tomorrow. Yeah. This one here is our main generator station, our standard generator station. It has it has all of the instruments and everything we need. This one is a second generator station, so this is made to be used together with this one. A lot of the things are the same. It's built on the same kind of design. If we look at the top here, we have our controls, and these are our controls for our motor or turbine, prime mover controls, and then our generator controls. Here we have our measurement instruments for the field for our generator. This is our produced voltage and also a stepped up voltage up to the bus bars. This panel is exactly the same here. These ones here are our connections for our generator and transformer. And the reason we have so many connections like this is because sometimes if you want to come in and do experiments, you want to come in and measure on the windings and that sort of thing, we have all of these connections. That means we need to make them first before we can do anything. Usually after we do this, you don't need to disconnect. I'm just doing it the first time.
The whole button here is just measurement.
Transformers at the bottom here and 3 at the top. These 6 current transformers are connected to our relay protection. This is an all-over protection. We have 6 more, which are just on either side of the generator. So this is a dedicated generator protection, which is this one here. Yes.
So we have to connect them before the experiment.
We need to connect them today. After they're connected, you don't need to take them off.
Any free CTs you have
Any free CTs
that we can use?
Maybe live there.
we have in the system are used for something at this stage. Yes.
But sometimes to show how the reverse power work,
Mm-hmm.
sometimes we shut down the turbine, which is the motor.
Mm-hmm.
You can shut it down. Right? You disconnect it. Because you said once you connect it, you don't need to.
Aha. Once you have used these connections here, you don't need to take them out again. Exactly. Yeah. So we'll begin with connecting these up in the right way. Someone can use this at the same time. So, where are we? I can.
Combination of UVW and radial blue.
Y connection or
Of course.
stop connection?
So first, yes, exactly, just a straight connection over.
Already connected. Sulaiman. Transformer delta connected. There is no
Yes.
any indication whatever DY11 or
Is represented by this one. So this is exactly on the
So this is the neutral.
yes.
yeah, this is neutral.
So we've created.
Why there is two CTs in the neutral?
Yeah, because this one is paired with this one at the top here.
Okay,
So
for
these
differential.
two, yes, exactly,
Unit protection.
and that's
Generator and
differential
transformer.
all the way through,
Yes.
which is this one here.
And what about that one?
So in this particular unit, we don't have a second protection here. So these are not used,
You
exactly,
have to short them.
exactly.
Okay.
So we'll short these out, this
Short
one and this
these,
one.
CTs,
But however, in this one, we do have a second relay
We
here,
have here. We have.
connected as far as we can go.
We don't need to connect them?
No, just for now. Just for now, we won't connect these ones just yet.
Okay.
If we look at our connections here, we have our neutral through our generator, and then we have connected into here, very good, into the delta, and we've created a delta. Here we have also created a delta. This unit for the differential needs to know the clock of the transformer. It's programmed for, at the moment, 5 o'clock. So depending on how this one is connected, it will be right or wrong. So we will tell as soon as we start to load, it might trip. And if it trips, we know that we need to either change the clock here or change this one here.
Have you got any procedure for connecting this in the manual? for the
Yes.
students?
Yes, there is.
Whether it's
sorry,
DY1,
all of-
DY11 or
All of the things we are doing here, there are procedures in the user and experiments manual, the main manual. So everything that we're doing, all of the connections that are...
yeah, it's just delta, but
Okay, so we have the delta. Next one is we have star or Y, and we need to create a neutral point in that one. So we have our these ones here.
neutral point.
And we need to take this one past our top group of CTs.
Need more
Red, yellow, blue wires.
Can I have yellow, please?
Final one. Get the color. And we should make sure these are all in properly. Okay, so now we can see that we have from our neutral point, past these two capacitor banks, past the generator windings, past this capacitor here, into the delta, into the Y, and past these ones here as well. Then we come to CB1, and CB1 we can see is here. So all of this path is the same as this path here. So, yeah, same path. So we have a generator, transformer, and CB1. Yeah.
Just quick question.
Yes.
You have the generator now connected in Y connection,
Yes.
and it's grounded. in the
Yes.
robot. Can we connect in delta? Is something? Is it?
We're not usually doing that.
Okay.
I don't see why you. Yeah.
Usually
No,
the
none
machine-
of our documentation is
Okay.
to do it. Yeah. Okay. So this is our power connection anyway. So that's great. We have power, but we don't have any protection on this part of the line just now. So that's when we're going to connect first this one. So these bottom three and top three, we can connect across.
There is earth protection, right? This is, could you said the read go to the neutral? in case of any unbalance or anything.
Sure.
It could
There's 6 or 7 different types of protection. So we will make some earth faults as well. Yes. We will demonstrate each of these different types of protections.
يا راجل الطيب.
We'll discuss the protection
this one مهمة.
Yeah, I think after lunch,
أنا أعتبر
first we will start the system and then we'll move on to how to do protections. And
specific questions will be later. Right?
yes.
تكتب
راشد
كده
راشد
notes.
راشد يكتب.
لا لا لا
لازم-
notes. لا هنا don't touch عشان ما يجيش طالب يكروس كده يروح شايل لك واحدة اتنين كده.
Excuse me, I think the
Yes.
downstream one also, right?
Yes, so these ones we
Because
can take straight across as well.
No, but how do we connect the cities from the downstream to the upstream now?
Okay, in behind, these have connections
Internally.
internally to them. Yes.
نركبه كل مرة واحدة ونريح راسنا. كل بعدين ركبه. ها؟ لا كله ركبه مرة واحدة. Step by step.
But these normally will not be removed once you
لا
No.
ما هو أنا بقول حتى تقول no touch لا بس هو على أساس
It's good to see once.
قبل
لا،
قبل
ولا-
ما يبتدي التجربة لازم أنت عارفين طلاب
But the
كده.
student, they will understand if you explain to them.
Sure.
If it is built in, you cannot talk to
لا
them.
لا
But
اللي
that
أنا
would be like-
أقصده ترايت لأن في طلاب بيكروس
Okay. In this particular model, since we don't have a protection here, we need to short circuit these ones. So we just take one from here to here.
We need to isolate this one from this one.
We're just short circuiting the secondary winding.
I have a
But
question.
here-
Why you add a protection to that one and you did not add to this one?
Yeah, this one is a complete system, and this one's more of an additional system. So it could be purchased with the same relays, with an extra relay, but you don't really win any more functionality. In this one, we can already demonstrate this one here, so we don't need to. They're quite expensive, and we have an online tap changer. This has just continued for the last 10 years, maybe 15 years. If you want to demonstrate taps, then you can use this, but
هنا protections نعم. هنا شيء protection.
okay.
What we'll do with the last stage now.
So this one is internally connected
Inside.
to our CB. So now we have made all the connections we need to. Yeah.
This is just for measurements only?
Just for measurements, exactly. If you want to have a multimeter, something like that. These, as I said, we don't really need them because we have all of these instruments here now. In earlier times, these instruments weren't available, so it was good to have somewhere to put multimeters in or something like that.
You can use them for demonstrating protection function. They short circuit one of the CTs so that it will operate.
Sure. Yeah. And we will do that
Okay.
once we have the system running.
Yeah.
So, yeah. A lot of this time we'll spend on making all different types of faults and see how each of these protections work, the different types. Okay, so we're ready to operate. Let's start. I can talk just briefly about this unit here. So I need to come around in front of here. On this one. This top panel here is all of our synchronization equipment. So the synchronization equipment, we have a couple of bus bars, we have a synchroscope, rotating phasing lamps to make sure that the sequence is okay. And we have this position selector switch. So we can synchronize at different positions on this module. And we do that here. Position 1 is CB1. So if we want to synchronize around the CB, we would select position 1. CB2, this is the best one to synchronize around because that's why it's here. But we can also choose to synchronize around CB3 or CB4, and we do that through here. You can do manually or semi-automatic. And by semi-automatic, it means that we can connect everything and tell it to wait for the parameters to be correct. But then we must manually adjust the speed and the voltage.
The last you switch on, to look to the synchronous because this should be hand manual, right?
We can do both.
Oh,
Ah,
the-
yes,
the
this
last-
one.
The last step.
The last step can be manual or auto. Yeah. Yes.
Synchronization relay or check relay. Is it connected between the bus and each circuit breaker, or
Yeah.
you said just two sides?
So these ones, this and this and this, we can move these internally. So we can use it to monitor above this one and below this one, or here and here, or there and there, or there and there. But we'll demonstrate that now on what we're doing.
Yeah, just say one question.
Mhm.
So that means this is the main generator that should be on before, right? In order to understand, should be on, and then you will synchronize this one.
Yeah,
Because
the
the
order
option-
doesn't really matter. You can bring them on at different times as long as you come around the CB.
There's no
But
option.
it's easier to demonstrate, I think.
Yeah, but because I can see only on this one, not on this one. So this.
Yes. Yeah. If we continue and we can demonstrate,
Okay.
and then we get a better idea.
So like,
Okay, so that was our synchronization equipment. We have this IED here. This is our main protection all over, and it's covering the transformer and the generator. We see here. This one is our generator protection only. So this is these two here on either side of the generator. They have similar functions. They both have differential protection. This one has, they both have overcurrent of different levels. This one has a few more: earth fault, negative sequence overcurrent, voltage, under voltage, over voltage, and residual over voltage. Also, we have frequency protection in this one as well. So we will go through and make all of these faults. Here we have our outgoing lines, 2 lines to choose from, which also have their own protections, feeder protections in this case. And here we also have overcurrent. We have a directional earth fault protection, so we can make faults on this side and faults on the back, and it should react for these ones, but not for these ones. And that allows us to divide up into different zones. Negative sequence, we have phase discontinuity, so if the lines are cut, and also some auto reclosing. Yes, in these ones. So,
reversible relay is good there?
reverse power, not in this one.
No,
we have
the generator, yeah.
not in this one either, but there is in the one that you are leaning on beside here.
But I come to Dr. Rashid questions.
Mhm.
It seems you synchronize this generator with the grid, the one.
Yeah.
What about the other one?
Yeah.
Is it should be on all the time, but we can also synchronize with the grid. You know?
I can demonstrate
Well,
now.
but we
So we
can.
do.
you know,
Yes.
We can,
Yes,
is-
3 is
That's
easy.
okay.
Yeah, with this system. Okay,
Thank you.
no problem. Okay, the grid, which you talked about. We have a connection directly connected to the local network, the local power network in here. If I turn this on, we can see
490.
almost 420 just now. And these connections here allow us to connect the grid up onto this main bus. So this main double bus here is the same as this one here. We see AHV, AHV, yeah. And so we're using that when we synchronize with the grid, which we'll do in the next step. Next panels, here we have a couple of contactors we can use. These we can use from SCADA as well. This one will demonstrate when we're connecting faults and things, if we want to connect them remotely. The next panel here is our fault simulation panel. This allows us to connect faults in a safe way. We have 2 different impedances. This one will allow quite large current, and this one will allow less current. We can make earth faults. We can make phase-to-phase faults and things like that through this. Sorry?
Fault current?
Fault current is dependent on how much resistance you're using.
Maximum.
Maximum in this one, we have a protection to protect the rheostat for 1.5, but that's quite slow.
Impedance
Yeah.
relay.
Sorry?
Impedance relay.
Impedance relay. Here we have an impedance relay for this one. Yes. This has a distance protection as well as reverse power protection. Yes.
Yes. For synchronization.
Yes.
See that you have an option to connect to circuit breaker 1.
Yes.
But I see circuit breaker 1 is here and there also.
Okay. Yes. So these ones are local circuit breaker ones.
The second generation.
So in this module, I think.
Okay.
Yeah.
Yeah.
So this one is out of that.
Yeah, because this one doesn't need to be here. We can actually move this to a different place, anywhere in the system. So this one can be like a floating
So it has
generator
nothing to do
system.
with that
No,
selecting.
that's correct. That's correct.
So, how many selections here? 5 selections. This is 1, this is 2, this is 1. Where are the other
Yes.
selections?
It's in that side.
On the outgoing lines,
3.
so maybe you have some power which is here, and you have some power which is here, and you want to connect them together.
Okay.
Yeah.
3, 4, and 5 maybe.
Okay. Yes. So let us get started. Do we have 10 minutes maybe? No, we're. Should we take a break?
Represents the whole set.
Soft module.
Yes.
What do you mean?
So I can simulate what I can see, I can show, I can check it before I come to here.
Aha,
I
okay.
can test it, I can do different things.
Sure. You have the ETAP software
Yep.
installed on each of these computers, which is the answer is no, not from us. With ETAP, I'm not sure. That's not something we are using.
Can we run the program inside the PC without running the modules here? Is the
You'll find in here. For example, we have the connections that we've just been making.
This manual is, I think, available in PDF
Not. There are 5 or 6 manuals. I can. These ones here. So this is the main user and experiments manual. It has procedures for all of the experiments that we will do now. This one is a supplement. It's for the protection relays. And here we've taken information from the ABB manuals, which are about 2,000 pages each, and just compiled the most important information in that one.
What, 1 copy each,
I think there's 2 or 3 printed, and then you'll get soft copies tomorrow. Yeah. A SCADA manual on about how to administer users and things like that. Here we have some experiments for the distribution and transmission lines only. Here we have a manual for the distance protection only. This is for a standalone trainer, but the actual relay is exactly the same as we have here. Yes. So there are some manuals here, and tomorrow you will get soft copies. And if we don't have the soft copies tomorrow, you can tell Henrik off. Yes. Okay. I was going to mention something about the logical blocking. In the PLC, there is blocking to make sure we do the correct operations on the CBs and the disconnectors or the isolators. Obviously, in real life, we're using CBs to make and break power connections, and we're using isolators to route the power in different directions. So first, when we're making connections, we must operate, say which way we want the power to go, and then we connect the power. So if we do that, that's fine. If we do it in the opposite order, first we put power through here, and then we try to make a connection with this one. This one is saying, no, we can't do it. Behind this switch, we have a contactor. So when we close the switch, we send a signal to the PLC, and the PLC will check to see if it's okay to close the contactor. And if it's not okay, the contactor stays open, and the light comes on. If we
What type of switch you are using in the hardware? Is it CDs or contactors?
They are contactors behind each of these switches. Yes. Yeah. So if you try to connect and it lights up, you've done something wrong in the logical order. Okay. There is some information on that here. I was looking for here somewhere. But I think it's very natural. Once you start using, you'll get used to it very quickly. Okay. What we're going to do now is start to operate the generator and the turbine. Here we have a chapter on that, the procedure. We don't really need to go through and follow this one. Yes. Motor and turbine controls. Here we have the speed control, setting the set point. Here we can see the set point that we set, 50 hertz here.
Yes.
Yeah. Coarse and fine. Just to make it set, it's very easy. Here we have 4 different acceleration times for the motor. They're to simulate different startup times. The slowest one is 12 seconds to simulate a hydroelectric turbine. The fastest one is about 1 second, something like that.
Fixed group.
So
Fixed group.
fixed group? Yeah.
Group. DROOP.
Fixed group, yes. Yes. Exactly. Okay. The motor or turbine has a feedback option as well. So we can run it manually, and we do that when we're doing experiments where we want to see that the generator will slow down. Or we can have it in auto, and that will hold the generator or the motor at that frequency. Same with the generator. We have feedback, auto and manual, if we want to hold the voltage at the same level, or sometimes we want to see the voltage sync. Or, as in this case, when we want to synchronize with the grid, we want to have these in manual because we don't want our equipment to try to fight against the grid. It won't win and it might damage the equipment. It won't damage the equipment, but we might get some trip, something. We have our run and stop. This is where we start. Here we have start and stop, and also our coarse and fine controls. Yeah. So we begin. Start the turbine. Very good. And then we can start producing some power. So if I turn this one on, you can see it's on. And I can start to bring up the field current here.
Yeah.
And here we see that. Excitation, sorry, yes, exactly. And here we see the voltage that we're generating, and then the voltage after the step-up transformer. So I raise this up to a system voltage around here somewhere.
415.
415. Yeah, there's fine. I will adjust it afterwards. So now we have power here. I'll bring this up onto our B bus. So I make the connection to B bus and then close it. So now we can see we have this power coming all the way here.
Yes.
I'm going to synchronize around CB2. So make sure this is on too, and it is. I'll bring a connection down there. So now we have some power here. Now I want to bring the grid onto this side. So we have our grid panel. Up here we have a free bus, which is our A bus, which is the same as this bus here. So first I make a connection to the A bus, and then I close the CB. So now we have this grid power on this A bus here, and I can bring it down around CB. So now we have the two different power. Here we can see they're actually quite close.
Yeah.
Here we can see this one's telling me that I need to go a bit faster. So I'm going to speed up. Motor, and there we go. It wants me to go a little bit faster, but it's okay. Too much, yeah. Yeah. So when the frequency's right, this one should light up.
Sync sign.
So that's okay. And this one here, do we know what this one means? The tops, the peaks are meeting at that point when it's at 12 o'clock.
No.
So that's when I can close this CB
Sync, yeah.
and sync. So if I try that now, there we go. We had a sync and we're synchronized. A second way I can do is if I make this a bit slower so it's not fast enough. There we go. We can put this on auto sync. And what that means is I can close this now, but it will wait until the parameters are correct.
Automatically.
So as soon as I make all of the parameters correct, it will connect itself when it gets to the top. So I adjust the speed manually, yes. So it's a semi-automatic. It's automatic closing, but not automatic control.
Yeah.
And there we go.
Done.
Yeah, so two different ways of syncing. Okay, so now we have both of these connected together.
So that means it's connected to the grid only.
So we have one generator and the grid.
Yeah.
Yeah. So if we now want to bring this one also onto to sync onto the system, we need to free up one of the buses. We need to make one of the buses free because just now both of them are connected. Yeah, exactly. I'll transfer onto the bus. So we can do that now. Now this will let me close our connection to the B bus as well because it's already got a connection here. So I can do that. And I take our grid connection away there. That won't let me do that there. I don't need to do that. Yes, I'm just checking something there. Yeah. So, there we go. Okay, so now we have our free A bus.
You synchronize at the same point. You bring the generator to that
Yes.
free bus, and then all right.
Yes, correct. For me, this is the most logical point. You can do it at different points if you want, but so there is no internal connection between this unit and this unit. So okay. Yes, so the next step is to bring this one online, put the power up onto the bus, and then repeat the procedure. Would someone like to start this one?
So we set up the speed?
So we set the speed. Speed's actually already set to 50, so that's fine. So we can just start.
What about this?
So first we bring the turbine online. Yeah. Very good. There we go.
In the field?
When we start, exactly, we make sure that's at 0 before we start.
Zero.
That's 0, yeah.
Start this.
Very good.
Then we clean the voltage.
Yeah. That's a covered.
That have to be here. So, for some students, they might.
So we want to use the A bus
The other one.
at the top there.
This one.
Mhm. Yes.
Is there now?
Okay.
Sulaiman, which one will do?
So now we should, if we look down here,
Excuse me, without
on here,
Oh.
yes. But here we see there's no synchronization.
Sulaiman, connect isolator, I3. Yes. Now it's ready for which type now? Is it manual or it's manual now?
So yeah,
This should be on.
On.
you can do it either way. Doesn't matter. But if we want to do manually, then that's fine.
So we just wait for sync and then we call CBT.
Yeah.
That's all.
So we need to make sure the voltage, the difference in voltage is good. The difference in frequency, I think, needs.
See it also from the monitor.
As well, yes.
But still, the voltage
We can see here.
Yeah, the voltage of things
Voltage
should
is
be
good, yes.
a little bit
Higher.
more.
Okay.
this
We-
voltage.
The
voltage of
All right, it's okay now. And what speed?
And the speed.
why not? Inshallah. Inshallah.
بعدين this one should be still on. The automatic is not sometimes.
Manually, more challenging. You can learn from it.
Yes.
But semi-manual, semi-automatic is not challenging.
Very close.
Yes.
So هنا في شغل 50-50.
We just want this one to move a bit faster, maybe. And then when we're at the top, we can close the CV.
I noticed that the response of this change.
Close the sync when this is not at the top,
Exactly.
when it's maybe a bit far away.
Yes.
Um,
Let it go a little bit.
it doesn't want to. There we go. Okay, so we have some movement away. I won't do it when it's completely down at 180 because that's a lot of strain for the system. But if we do it up at about here. The alarm, no loud, no. But we see here, and we see also we've disconnected this one now.
Isolated.
And also some unbalance, a negative sequence. After we get a trip, we need to acknowledge the trip. On this unit, we have trip reset here.
Disconnected. The generator is not connected to any load.
No, this generator was disconnected because we tried to sync when the peaks were not equal. Yes. Just to demonstrate what happens when we do this. So if the student does this, the system has protection. Sorry?
Actually, there is an overcurrent now.
Overcurrent? Yes, definitely.
Phase difference.
Yes. Yeah. And also some unbalance, but that maybe came when we disconnect. I'm not sure. Yeah. Okay, so we have a trip, and we will be having many trips today.
What do you think about if we disconnect the turbine? If you connect turbine, the generator will act as a motor, right? And the reverse about should be
Sure.
correct, right?
Mm-hmm. Yes. Yeah. Since we don't have reverse power, there's also some other problems that come as well. Yeah. Okay. So we can take away any problem if there's still some problems, and we hit trip reset, and that should reset all of the problems.
And then you start again.
Then we can connect again. Okay. Now I try to do the same again, but everything is closed there, so we try to synchronize one more time. So we got the same.
The same.
So
Yeah.
just reset it.
And now it's been even a problem in the motor as well. So the motor's seen a problem. So we also have a trip in the motor driver.
What type of trip that one?
This one we had over voltage at normal speed. So this saw an over voltage in the drive for the motor as well. So I turn everything off. This problem I can take away with this button. Anything here, trip reset. Okay. If we disconnect this one again.
The motor drive should be reset individually.
So, yes. Yeah. Okay. We can start again. I don't need to move these because I know they're in the right position. I had some school which was very against doing this. They wanted to always drive down to zero.
I am from this school.
Yes.
Usually I do like this.
During this kind of training, yes. If we're doing procedure, then we should always go to zero. Okay, so now we have that one again.
I think the motor is not.
No trip. It just says, I saw some overcurrent, but it's just a start. Yeah.
Because of the difference in the voltage. I saw a difference in the meters here. I
That's
noticed them.
Yes.
So now when you connect them, there's some reverse, maybe reverse power.
Yeah.
But not trimming.
Not really, but just an overcurrent.
Not enough to trip.
Not enough for trimming.
Yeah, we have some reverse power, but
Yes.
it's,
Should be.
but the power is going to the transformer. So we don't have the reverse power in the generator.
Okay, okay.
Just in the transformer.
This is right.
Yes. Okay, so from here we can also use one of these generators to adjust the power in the network. For example, this one is giving 100 watts of active power and receiving 103. So if we try to speed the motor up slightly, not too much, or slow it down, if I slow it down a wee bit, we can see we can adjust the active power with the speed of the motor. So now we're starting to consume active power here, very little. And with the generator as well, if we want to do something with the reactive power. Yes. So now I'm just adding some more field current.
So generator active power. Yeah. But you can make them sharing the load also. There's no load right now. So
We have no load right now,
Just
so
the
that's the
network
next
only.
step.
just the network now.
Yeah.
You are sharing the part of the network.
Mm-hmm.
But you can share them, I think, equally.
Yes.
Okay.
Also.
Is there any program so that they can share the power equally, or should we do it manually?
Most of these operations are manual.
Okay.
Yes. So the next step that we usually do then is connect to a load. We can connect directly through one of these transfer blocks.
One more question.
Yes.
If we connect them in parallel with a single load, okay?
Hmm?
So it's not connected to the network. Have you experienced any imbalance between the generators that they are maybe hunting between them?
We haven't been able to create this problem. We have tried to create it to be able to show.
Very good.
It's fixed droop, doctor. Fixed droop is not
Yeah.
automatic droop. It will have this frequency fluctuation.
Yes. Since we're just going to use the load directly, we can take from one of our outgoing lines and connect to a transfer block.
Need more wide?
Yes.
Long.
Longer. Blue, Slimmer. 1, 2, 3, So now we are connecting directly to the, and this one?
That's right. So now we have transfer block 4. 1, 2, 3, 4. And we're using number 1, 2, and 3. So down at the load,
Yes, you have the same number?
yes.
Right?
Pre-connected, exactly.
So,
So from here, if we want to see the power, we should connect into here first.
Is the root curve this one?
What is this curve?
This one? This is a dynamic load, automatic.
Then, what about the type of load?
Okay. So we will look at the different types of load, but first we need to make a connection from the outgoing lines here. So we have two isolators that we need to close first, and then the CB. So if you want to close those ones.
This one first?
Yep.
The second one.
And then this one.
Yes. And then the CB too.
Safe now?
Yes, that's correct. I can also talk about these instruments. There are some different pages going past here. Yes, from the bus bar. So this is like an overview page.
But since this one is an open load, so we have zero current.
Yeah, so we have no current just now. So now we can start by adding maybe one resistive load, which is at the top.
No.
Different from this part.
Different points, yes. So we have 32 different points. Yeah.
I thought it's the same point.
It's kind of common.
Okay.
Yeah,
Very good.
not uncommon. Inductive load and
We wish
resistance.
to have a bar factor here. You can read the bar factor here?
Yes.
From the manual.
30 seconds.
30-second harmonic, I think.
Up to the 30-second harmonic.
Yes. In the listener itself.
This one not on the display here, but I think in SCADA.
It can be.
I think so
Yeah, I
too.
think it could be, but they are not programmed. for it,
Okay.
Okay. Yes, so we can.
That there is some reverse power.
And
Now
also-
it's consumed from the network.
Yeah.
So it can be done from the network maybe for the time being. But scheduling the power from the generators may be isolated from the grid.
Mhm.
Can be done.
So if I talk about how to program this, there are different ways, or we can choose the top, how much load we want to be 100%, and we can program the time, the generation. Yes, exactly. We do that by putting it into the program mode. There we go. And now it's asking for our upper limit. How much load should we have for our upper limit? And just now it's set to 9. So we can adjust if we want less load or more
Directly
load.
going to the higher one.
Then how to acknowledge
So that means that when it's at 100%,
Yes.
then we will have 9
Okay.
load connected. If we're happy with 9, we click that one time and ask for a lower limit.
Zero.
Just now the lower limit is 0. Maybe we always want to have a little bit of
Little
load,
bit,
so we make it 1.
Base load.
And then it's asking for the rate. There are different times,
Rate of change of the load.
rate of change.
The duration of this changes.
Yes,
How
Uh,
to set it? How to set it?
it was the third one that we set. So if I go back to program, we have upper limit 9,
Lower limit.
lower limit we want to have 1, and rate. So this is the, let's make that the fastest. So, and we go back. So it begins
I mean
here.
if there is any different rates for the
Load.
cycle.
Yes.
Yeah.
Yeah.
You
So,
can just
so then we change from 0 to 1 or 2 or 3. So it can go half a minute, 1 minute, 2 minutes, 4 minutes, 5 minutes between each switch. Now it's, I'm not sure, 5 seconds or something. It's very fast.
and going back from upper to lower with the same rate.
Yes. It's just the time between each of these time points.
So it's the length of an hour.
Yes, yes, I know.
Yeah.
But the problem that just fixed cycle. I mean,
Hmm. Yes.
Just fixed cycle. It's
Yeah.
not.
There's no random, no randomness program into this yet.
And we can save those values inside the pieces automatically. I
Uh,
can lift the device that is running like this way and we can save it for certain times. We have to store it.
It doesn't need to be stored now.
If I need to start, for example, I can let it to be running this way.
Oh, you want to store
The result inside.
the voltage and the current values?
variation, load
Okay.
variations.
No, not at this point. No.
Maybe from scale then.
Um,
Maybe.
okay, so that was dynamic load anyway. We put it back to manual, so we're there. Okay. Straight those, make sure that's all working correctly and what we expect. So to do that, we will disconnect the grid and we'll just run one of these generators next time.
normally بس الجريد للسynchronization right؟ وبعد كده في الويب administrator experiment switching off this one.
So now I have no grid and only one generator. Yes, yeah. Just now we have these both in manual position. You don't need to be there. Yeah. Okay. So with both of these in manual, or even if I put the motor into auto, I can do that. So we should hold our speed when we start to load, but the voltage will probably drop. Hopefully the frequency won't drop because we have auto. We have some feedback in this one, and it should hold that position. So we try that one first. We make a connection to the load. So the current we are drawing here, 1.53. Here we have 1.58. We can see we've dropped almost 100 volts.
هنا في الهاي فولتج هتلاقي كرنت اعلى من سوري العكس ده اللو فولت اي لود.
So we can adjust this fine adjustment of the speed.
We can manually adjust with this if we want to. This is usually to show, particularly if we want to do some load shedding experiment, then we want to show that the turbine will slow down. Yes, so then we should have this in manual stage. If I disconnect now?
Yeah, sure.
So we have
If you put it on,
everyone.
if I put it in manual now, it return back to.
Yes, I connected again.
Should I put it in start no harm on auto?
With the motor, no, we should stop before we change. Really.
Stop the load.
Before we change from auto to manual, I mean.
What? Stop what?
Stop the motor, change to auto.
Okay, not
I got it.
directly.
No, I did it directly now. Oh, you can do it, but sometimes the measurements can be wrong. I have seen, yeah. So it's better just to stop it, change, start again. Then you can be sure of the measurements that's on here. Okay. Here we see we have a flashing red light on start earth fault. Once again, we've just had a start, so it's seen a problem, but the problem has disappeared before it has reacted and taken any trip. And that's probably when I've connected or something, disconnected.
Balance maybe.
Yes, so we can take this away just with trip reset. Okay.
We'll speak about the setting later.
Yeah, now we can begin to connect up through the complete system, and then we'll start to make some faults. And we'll talk about these ones here. Work backwards.
Downstream.
Yeah.
So CB first.
So from the downstream,
So that's right. We have 5 loads, so we should maybe take away the load first.
Set all of them.
Subtransmission there.
How to connect them to this transfer block?
Yeah. So we will directly connect through these ones now. Transfer blocks, yeah. So transfer blocks we're using if we want to come a long way away. Yeah. But now when they're next door,
it's near.
we can make connections.
Yes. You can connect, remove from the transfer block to the one of the overhead. Put it in the blue, please.
I'm from UK, not from you.
If we swap these in the next
We have to swap it also.
in the next display, it will give you an error,
Yes.
and it will say
He would
Which
like to
one
make
is wrong?
transposition only.
okay.
Remember, we are allowed.
Just now we have only connected series elements, components. We have also
Sending and receiving.
Short, short, medium, like.
Mhm.
I think this one is the short.
This one is quite as a long line.
Later connect the capacitor, it will be short, medium, or long.
Still, we have quite a long voltage, quite a big voltage drop over this line. But
Because this one, to model the line in
Mhm.
short, medium, you can connect the capacitor.
75
Uh,
100
اي لكن اذا غلطت هنا وما عملت
الشو
so this is with all of the components connected.
بس كلهم كاباسيون لو قال لك ده
محتاج نفس الكلام محتاج it depends on the application.
When we're connecting all of the capacitors in here, we get quite a large voltage boost, and it makes the system a little bit difficult to work with quickly.
Mm.
One question in this
Mhm.
do you have mutual coupling between the phases?
Here we have between this one and this one, for example. So just now it's not connected.
I mean inductive mutual coupling.
No.
In models usually there is a transformers.
In a pi model,
Yes, in the back, in the hardware. Are
no.
they segregated the RL circuit only? Just
There, as they look on the,
I mean,
Mimictogram
this
here.
board it's okay, but in behind.
yeah, it's exactly like this.
Okay.
Like it's.
Which
Yeah.
couple?
There is in lab volt there is.
The neglected coupling for longer lines.
Okay. So from the output of this line, we can come into the top of this substation here.
Receiving it.
Yes.
The problem that you haven't mutual coupling between R and yellow and or yellow and blue and long lines, for example, to simulate ZM mutual coupled impedance.
Har du någon kommentar om det?
Long line, this is what distance protection will be there for line, for coupling. It affect.
What is the distance protection?
I mean, if you
Mutual capacity.
I have mutual coupling.
yes,
We don't have it now, but
okay.
The effect of
Because usually in labs they didn't care about it. Some labs yes.
Okay. Yes, so now we have a connection into the substation. In the substation, we have some internal connections that we need to make as well. Here we have a star-star transformer with a delta winding as well.
So he's already taking the input from here.
So we have this one here, and we can connect through all of this. So once again, we have connections and
This
control
one is
here.
already internally connected.
Yes, exactly. But we need to make the connections inside the transformer. So on the HV side of the transformer, we need to make a Y connection here.
Is this two winding and three winding, not three winding?
Three winding.
Oh, three winding?
It's YY with a delta in the middle.
يعني Y and the two different voltages, right?
Yes, but not so much voltage drop.
Yeah,
Only
primary was different. Secondary, they call it three winding. What I mean, you know. What I mean, if you have one primary and you have two secondary, different voltage.
no, it's one and one
خلاص one.
with a
You mean
balance of one.
multi-coil?
لا لا يمكن مش في عمان هنا في قطر يستخدموا one primary و two secondary.
Secondary two sides.
two secondary يديله 110 و 220.
Okay, like
مفيش
like that.
No.
ازاي يعني هو ايه يعني؟
غير لو
يعني برايمري وحاطط two secondary.
So this one is the secondary side, this one here. So we need to make a neutral point here.
ويوصلهم بقى لللاين. مش في عمان.
Yeah, exactly. And this neutral point we can put to earth. We can do it by an impedance, by a resistor, or by Peters and coils, or directly.
No, the secondary side is Y, right?
Secondary side is
The high
Y.
voltage side is star connection. Then
Yes. Also star connection here. on the secondary side.
Okay. So star.
Yes. In the middle, we have this compensating winding, which is a delta.
Yes.
So we just need to connect that one there.
No, there are two pairs of seats.
Yeah.
Then the output from the low voltage side.
Yeah. Before we get there, we've made a neutral there. And the neutral we should probably put to ground, either directly or through an impedance. If we make it through an impedance, maybe. So now we have grounded the neutral. Yes, and we need to connect those ones.
Delta. No, this way. Delta is
No, this one's a Y connection as well. We have some more of these somewhere.
So I interviewed the
Here are two here.
Yes. Well, no. And then out.
So basically,
Now this one is protection.
Yeah,
CT.
exactly.
But there is no CT there. Also the primary side, the whole side.
Yes, so we need to connect these ones as well.
Okay.
it's different.
So it's connected.
Yes,
معناتها احنا نلعب
it's different heights.
Shall we start?
Yeah, yep. Whenever you're ready, we'll just connect all the way through to the load and start loading.
Run, right?
So we just press enter to bring the light on. We can see, okay.
He's doing it automatic.
No, it's just that this was already set before.
I see.
So auto is if, for this one, if we start loading the system, it will give more field current
To
to,
maintain.
yes, exactly. So these values are good. We can begin to connect through here. So we need to take an isolator and a
Yes.
circuit breaker.
Now, how can we make sure the continuous of the power from one station to another?
How can we make sure?
The continuous of the power, I mean the transferring power from one side to another.
Mhm.
From here, for example, you
Yes.
can check it, right?
So we can see here, and then when we come into the next station,
Yes.
depending on where we connect,
Receiving.
this one or this one,
Okay.
and then when we go out,
This is what I mean. Yeah.
and then when we come in,
This
this
is
one.
what I mean. Because sometimes
Yes.
we'll have break evens. You know?
Mhm.
You have to check it.
Yes.
So we start with this.
Just now we have one line, which is on this side.
will not let you.
So sometimes when we connect, it will see a small spike something, so we can just push a trip reset. That should take away. Yeah.
We are missing four scopes here.
It's going to show us what the actual power factor in the load is. So if we make a very bad power factor here, we can see
Yeah.
something bad here, maybe 0.5, something like that. After this has compensated, we can see the actual power factor that the network is seeing further back. Here we have some, just the current going further, current going out and current going.
Now first, خلينا نعمل لك resistive load.
Yeah, so we take maybe 3 resistive loads, something like that. We can see we have a power factor of 1 in the load, and here we have a cost fee of 1 as well.
One, yeah.
So that's about right.
Unity power factor.
Yes. If we start to add some inductive load, I add 3, quite a lot. Here we see the power factor in the loads,
The
very
current.
bad. That's the current, yes,
The sending current, this is the receiving current.
exactly. So now we can see there's been 2 steps connected in. This is still showing 0.61, a bad power factor, because that's the load power factor. But if we look in here,
One.
we can see we have actually a power factor of 1. And we should still also be able to see it in the instruments, in this last instrument here,
You have the line as well. So
with the line as well, yeah. Quite close.
Receiving things we can control it.
Yes.
Because we need to correct the power factor on the
Disconnect. So now he's disconnected 1. And he's going to disconnect more, and it's disconnected too, and that's okay.
Resetting.
This switching can be programmed. There's a manual, complete manual on all of the features of this particular unit. It takes about 2 days to go through to try all of the things. One of the switching schedules you can do is, just now we are beginning always at 1, but if you have proper capacitor banks, you might want to use them all equally. So at the moment, this one will never get connected unless we have very, very, very bad power factor. But one of the ways you can change this is that it will take the next one which hasn't been used. So next time, this time we connected in 2. So next time we have a bad power factor, he will start here and connect that one. And then next time we'll start here, and next time here, next time here. So it shares all of the load through the power.
At which setting this?
This one is called cyclic or linear switching. It's a parameter in here. There's all of the instructions on how to change, where to find this, and how to change it in the power factor controller manual that we have. That's one of the things. The next one we can do is make, just now, all of the banks are the same size. They are
0.3
0.3
kilowatt
kilowatt per bank.
per bank.
Yes.
This is the bank one.
Yes. And this knows that we have we have configured this one
But
to know
make sure the voltage is 400.
at 400 volts.
Yes.
Yeah.
Maybe if it's less, so that the voltage will be less.
But what we can do is we can connect some of these together. So we can have the first one as a single bank. We connect the next 2 together, the next 4 after that. So we have like a binary system. Then we can program this and say it's a binary system. So then he knows, okay, if I need 5, I connect in 1 and 4. So there's a lot of different things that you can do with this. But the basic function is the same.
Why is that we have 12 here? We have 18, right?
It's just for space. Yeah. So it continues. Okay. We have some lines which have very big capacitance because they're very long lines, which can cause a big capacitance. And here we have some compensating inductance as well. So if we were to connect this capacitive characteristics, yes, in here, then we can compensate for that just by switching on this one manually. Yes, yes.
Can you repeat again on this one? I didn't finish.
Yes, in the lines,
Yes, transmission line.
transmission line especially, if we are to connect all of the capacitive
To the neutral.
components,
Yes.
line to line here, and also line to
Together.
neutral, yes.
Okay.
Then there's a lot of capacitance,
Yes.
so we want to compensate for that. And we can do that by using this bank here,
Okay.
for example, and that's just an on and off.
No
We-
need to make
we
it
have to-
manual, make connection.
No, not just now. We don't need to do that. Creating faults and look at the relays.
This is the guys, he's troubleshooting, you know, troublemakers.
Yeah.
He can make the faults.
Troublemaker.
Troublemaker. Yeah.
Okay.
He can make the faults.
First, I'll do a small introduction on here and just give you some information. But it's about 15 minutes to lunch, so I think it's a good place to stop.
Exactly.
And we continue after lunch.
I like you.
Yeah?